Now we will see about one component system in phase equilibrium. The example for one component system is water system. Under normal conditions, the system, that is water, is in a three-phase one component system. Three phases involved are ice, liquid water and water vapor. The phase diagram with the plot of pressure versus temperature of water is shown here. The phase diagram consists of three areas, that is AOB, BOC and AOC. Three stable curves AO, OB and OC. One metastable curve OD, one triple point O. First we will see about the areas. The phase diagram consists of three areas, that is AOB, BOC and AOC, and each one represents a single phase, that is AOB represents solid state, BOC represents liquid state, AOC represents vapor state. It is necessary to specify both the temperature and pressure to define the state of the system within the area. Hence, the system is bivariate, that is F is equal to C minus P plus 2. If we substitute the value of C and P in this equation, F is equal to 1 minus 1 plus 2 will give F is equal to 2. The curves A or line separates two phases and the system the univariant along the curves. F is equal to C minus P plus 2, that is F is equal to 1 minus 2 plus 2. From this, F is equal to 1. Curve AO separates the solid and gaseous phase. It is the sublimation curve of ice. And curve OB represents the equilibrium between ice and water. Thus, it is the melting point curve for ice or freezing point curve for water. The curve has a negative slope. It is inclined to the pressure axis. This is due to the fact that the molar volume of liquid water is lower than that of the solid ice. So, the negative slope of the curve predicts the melting point of its lowered with the increase of pressure. And curve OC is the vapor pressure curve of water. Along the curve, water and its vapor exist equilibrium at different temperature. C is the critical point. P equal to 217 atmosphere and T equal to 373 degrees Celsius, above which only the vapor phase exists, whatever may be the pressure. And metastable curve OD, it is possible to cool water below its freezing point without solidification along OD. Now water is said to be in supercooled state. The curve OB, the dotted line in the above figure, is the continuation of OC and hence it is the vapor pressure curve of supercooled water. This means that the supercooled liquid is energetic and not quite stable. It is usually known as a metastable state and is readily changed into the stable state by slight disturbances or introducing a crystal of ice into it. The triple point O, the three stable curves OA, OB and OC meet at the point O, where all the three phases coexist in the equilibrium at this particular point. This is called as triple point. At the triple point, the system in invariant state, that is solid to liquid, liquid to gas. If this is in three phase, if we substitute the value of C and P in this equation, F is equal to 0. At triple point, P equal to 4.58 millimeter and T equal to 0.0075 degrees Celsius. When P and T of the system is changed at the triple point, one of the phase would disappear and the system will no longer be invariant. And we will see about effect of temperature on the equilibrium. At 1 atmospheric pressure, water is in the form of ice at the point M. When ice is heated at constant pressure, the system shifts along M and Q, and at N ice melts. It is the melting point 0 degree Celsius of ice. Beyond N there is no solid phase and we get liquid water up to Q. At Q water begins to boil and it is the normal boiling point of water 100 degrees Celsius. Next we will see about sulfur system. The phase diagram for sulfur system is represented in this figure. Sulfur is one component, four phase system. The four phases are two solid polymeric forms, polymorphic forms. Rhomic sulfur is represented as Sr and monoclinic sulfur which is represented as Sm. And liquid sulfur Sl, vapor sulfur Sv. Sulfur exists in two allotropic forms Sr and Sm. The two forms are in equilibrium with each other at 95.5 degrees Celsius. This temperature is called as transition temperature. That is, at this temperature Sr is transformed into Sl. It is defined as the temperature at which one stable form of a solid is transformed into another stable solid form without any change in the temperature, pressure on the system being 1 atmospheric pressure. Sr is stable below 95.5 degrees Celsius, whereas Sm is stable along this temperature. So the phase diagram consists of 6 stable curves AB, BC, CD, and then BE, CE, EG, and then 4 metastable curves BF, CF, FE and BH. The triple points are D, C and E. One metastable point is F. The 4 areas are A, B, G and which is marked as rhomic sulfur, BEG which is marked as solid monoclinic sulfur, GECD marked as liquid sulfur, ABCD marked as vapor sulfur. Here the curves representations are given. AB is for sublimation curve of Sr. The two phases present in equilibrium along this curve are Sr and Sv. BC is sublimation curve of Sm. And the two phases present in equilibrium along this curve are Sm and Sv. CD curve is the vapor pressure curve of liquid sulfur Sl. The two phases present in equilibrium along this curve are Sl and Sv. BE curve, which is a transition curve and represents the equilibrium between Sr and Sm. CE curve, which is a melting point curve of monoclinic sulfur Sm. It represents the equilibrium between Sm and Sl. EG curve, it is the melting point of Sr. It represents the equilibrium between Sr and Sl. A curve or a line separates two phases and the system is univariant along the curve. That is, C is equal to 1 and P is equal to 2. So it is univariant. And the areas, the phase diagram of sulfur system has 4 areas which we have mentioned already. And these are labeled as rhomic sulfur, monoclinic sulfur, liquid sulfur and vapor sulfur. These represent single phase system which have 2 degrees of freedom. That is, one component, one phase. So F is equal to 2. And the triple point, there are 3 triple points, that is B, C and E in the phase diagram. At the point B, 3 phases are in equilibrium, that is Sr, Sm and Sv are in equilibrium with each other. Similarly, C is also triple point. In this point, Sr, Sm and Sv is in equilibrium. At the triple point, the system has no degrees of freedom, that is all of them exist in 3 phases, so T is equal to 3. If we substitute this in the above equation, we will get F is equal to 0. And finally, the metastable curves BH, BF, CF and EF, the dotted lines represented in the above figure. The curve BH is for the transformation of Sr to Sv, and BF is for transformation of Sm to Sv, and CF for Sl to Sv, and finally EF for Sr to Sv. The metastable triple point is in point F, that is from Sr to Sl to Sv. Thank you.